You know, we see it every single day. It's the star that makes all life on our planet possible. But think about it. How much do we really know about the sun? It's so familiar, right? But it holds some of the most extreme, most incredible secrets in our entire solar system. So let's take a closer look, shall we?
Okay, to really wrap our heads around the sun, we've got to start with its sheer mind-bending scale. 1.3 million. That's the number. And what is it? That's how many Earths you could cram inside of it. Just imagine that. Our entire planet, our whole world, is just a tiny, tiny speck in comparison. It's just unbelievable.
All right, so here's our game plan. First, we're going to get to know our star up close. Then, we'll dive right into its solar furnace. After that, we'll check out its turbulent magnetic side. And finally, we're going to look into the sun's epic future. Let's get started.
Okay, first things first. Let's get to know this celestial engine that powers our entire solar system. I mean, what is this star at the center of our lives, really? What's it made of? And just how much does it dominate our little corner of the galaxy? Let's find out.
Well, a quick look at the sun's vital stats tells you pretty much everything you need to know about its complete and utter dominance. It's about 4.6 billion years old, so it's a nice, stable, middle-aged star. But the mass, wow, the mass is what's truly staggering. It accounts for 99.8% of everything in our solar system. Think about that. All the planets, all the moons, all the asteroids. We're all just cosmic leftovers. The whole shebang is basically just the sun.
So what's all that mass actually made of? Well, it's not rock or metal like Earth. Nope, it's a gigantic, almost perfectly round ball of superheated gas. We call it plasma, and it's made up almost entirely of hydrogen and helium. You know, the two simplest and most common elements in the whole universe.
All right, now for the really cool part. Let's peel back those outer layers and take a trip deep, deep into the heart of the sun. We're going to find out how this incredible solar furnace actually works.
Everything, and I mean everything, starts right here, in the solar core. This is the sun's engine room, its powerhouse. The pressure from all those layers above is just so immense. The conditions are so extreme that it literally crushes hydrogen atoms together to create helium. And that process, that's nuclear fusion.
Just how extreme are we talking? Well, the temperature hits nearly 16 million Kelvin. To put that into perspective for you, the surface that we actually see is a cool 5,800 Kelvin. This core is just a realm of unimaginable heat and pressure. It's the only place in our entire solar system where this kind of energy generation is even possible.
And the rate of this fusion is it's staggering. Get this, every single second, tick, the sun fuses 600 million tons of hydrogen into helium. And in that tiny fraction of time, about 4 million tons of matter gets converted directly into pure energy. That's the sunlight, the heat, that travels all the way to us here on Earth.
So, okay, all this energy is created in the core, but how does it get out? Well, the first part of its journey is incredibly, and I mean incredibly slow. It has to get through something called the radiative zone. This place is so densely packed with plasma that a little particle of light, a photon, can't go more than a tiny distance before it gets absorbed and then spat back out in a totally random direction. It's like a cosmic pinball machine on an unbelievable scale.
And because of this crazy random walk, it can take a single photon somewhere between 10,000 and 170,000 years just to escape this one layer. Seriously, stop and think about that for a second. The sunlight that's warming your face right now, it began its journey from the sun's core long, long before modern humans ever walked the Earth. Just wow. Thankfully, the final leg of the trip is way faster. Once the energy gets to the convective zone, the plasma is a lot less dense. Here, it acts just like a pot of boiling water on the stove. You've got these huge columns of hot gas rising up to the surface, they release their energy as light and heat, and then the cooler gas sinks back down. It's this constant, churning, boiling motion that finally brings all that energy to the surface. Okay, so now we get how the engine works, but what about the surface? Let's take a look at the sun's chaotic and surprisingly violent weather. You know, from here it looks like a calm, steady ball of fire, but that couldn't be further from the truth. It's a roiling, turbulent world of intense magnetic storms.
And the key to all this crazy activity? It's the sun's super powerful magnetic field. See, because the sun is a ball of gas, not a solid rock, different parts of it spin at different speeds. The equator spins way faster than the poles do, and this funky rotation twists and tangles its magnetic field lines, just building up incredible amounts of energy, kind of like twisting a rubber band tighter and tighter and tighter.
So, what happens when those tangled up magnetic field lines get so twisted that they poke right through the surface? Well, that's what creates sunspots. They look dark, but it's not because they're black, they're just a little bit cooler than the super bright plasma all around them. And why are they cooler? Because that intense magnetic field is literally pushing down, blocking the hotter stuff from below from reaching the surface, right there.
Eventually, that twisted rubber band has to snap. All that built-up magnetic energy has to go somewhere. Sometimes it releases in a solar flare, a blinding flash of radiation that is, get this, the most violent type of explosion in our entire solar system. Other times, you get a coronal mass ejection, or a CME. This is less of a quick flash and more of a colossal burp, where the sun just heaves billions of tons of plasma out into space.
So, we've seen the sun as it is right now, this powerful, turbulent star. But it won't be like this forever, not even close. For our last section, let's zoom way out and look at the sun's entire life story, from its birth all the way to its inevitable, fiery death.
Now, first, the good news. Don't panic. The sun is only about halfway through its main, stable hydrogen-burning phase. It's got plenty of fuel in the tank to keep shining just the way it is for another 5 billion years. But when that fuel does start to run out, well, that's when things get really dramatic.
And this timeline here pretty much tells the whole story. You can see it all, from its formation in a cloud of gas and dust billions of years ago, to right now where it's a stable main sequence star, all the way to its future as a swollen red giant and its final, quiet fate as a tiny, fading white dwarf.
Okay, that red giant phase. This is the most dramatic part of the transformation by far. Once the hydrogen in the core is all used up, the sun will start fusing helium instead. This causes its outer layers to just swell up to an unimaginable size. We're talking up to 256 times bigger than it is now. It'll get so big that its expanding layers will completely engulf Mercury, Venus, and yeah, almost certainly Earth as well.
And after that giant phase is over, what's left? Well, the sun will gently puff away its outer layers into space, creating this beautiful glowing cloud we call a planetary nebula. And right there in the middle, all that will be left is the hot, dense core. A white dwarf. It's basically the sun's stellar corpse, and it's destined to just slowly cool and fade away for trillions of years. Which brings us to a final, pretty profound thought, doesn't it? The very same star that gave us life will one day take it all away. This cosmic cycle of creation and destruction, it plays out across the universe, over and over again. So, what does this huge, vast, indifferent timeline tell us about our own brief, precious moment in the sun?